So let's return to the example we did last week in class, and let's run the brute force algorithm on this instead. I believe we did the nearest neighbor algorithm on this particular graph, but let's just try the brute force, which again, I'm not going to have you do, but just for those of you who want to see an example. So in this case, we have 4 vertices, thankfully. And again, I'm not going to do it for anything more because that would just be horrible. So we're going to have 4 minus 1 factorial Hamilton circuits that we need to find all of those, which is just 3 factorial. Thankfully, that's just 3 times 2 times 1, which is 6. So basically, I need to find 6 unique options. And we could draw a graph and so forth as we did before, but one of the things about brute force is the graph is not necessarily going to help us. Since we're going to need to find all of them anyways, it's probably just going to get in the way. So instead, how we could choose to do it is just by listing all the permutations of the letters. So say, for example, we're going to start at A, or wherever you want to start. I could just list the vertices in order. So like, for example, I could do alphabetical order, A, B, C, D, A, or I could do A, B, D, C, A. Kind of like how I taught you guys to find all the permutations with Shapley-Shubik. You could do the exact same thing. Though notice I'm just going to start and end at A always, so really I'm just focusing on the permutations in the middle. So A, B, C, D, A, A, B, D, C, A. That's the only way to do A, B. I could also do AC, which would be D, B, A, or AC, BDA. So notice how I'm like fixing 2, permuting 2, fixing 2. And then I could do AD, BCA, or AD, CBA. And that would give me all 6 of my unique Hamilton circuits in this case. And then I need to find the weights of each one of those and choose the best option. So A, B, C, D, A. So I could do that by circling them all. A to B is 121. So actually, let's just pull up a calculator and head right now. A little bit this way. Calculator. And now I'm in the way, so let's move me over there. Here. Okay. There you go. So I got too much going on. But if I'm doing a BDCA, so that's going to be, I'm going to be starting with AB is 121. Then B to C will be 89. Then C to D will be 212. Then D back to A is 5. And that should be our first bit, which is a net weight of 697. That one. And I need to run through all of them and compare, find the best. So let's just do it. I really don't want to, but we're gonna do it. For those perfectionists out there, you probably want to see it through. I am very resistant to it because I'm not going to make you do this algorithm, and it's quite tedious. But let's just do it. Okay, so AB is still going to be 121. Then B to D is going to be 347. Then D to C should be 212. Obviously going to be worse. And then C back to A is 206. So that circuit was 886, much, much worse. Need to find all the weights and choose the cheapest. Okay, next up, ACDBA. AC is 206. Actually, notice that ACDBA is exactly the same option as there. So kind of as I said, half of these will be duplicates because this one is just the previous, this previous option backwards, ACDBA. This one is a CBDA. This one is not unique to any of those, so this one will actually be worthwhile. And that's kind of why I was saying you could cut it in half. There's really only going to be 3 unique answers here, a maximum of 3 unique answers. So if we were to do a CBDA, this should be our last unique answer, which would be And again, I'm all about working smarter rather than harder. Um, so AC 206, C to B is 89, B to D is 5, and D to A is 2. Wait, I already did that. B to D is the one I missed, which is 347. That's not one we want, but there it is, 917. That is our third option, assuming I did not mess that up, which if you ever see me make a mistake in these videos, just let me know in the comments. I probably won't fix it, but it'll be a good discussion point, and I'll just pretend that I did it on purpose. But anyways, I think that's cool. It's good enough because, anyways, our best option was the same option we found um, from nearest neighbor algorithm, which is a total net weight of 697, and there we have it. And if we look at the other two, those ones should also be duplicates for the reasons I mentioned. But notice the ADBCA is just the 917 backwards, and ADCBA is just ABCDA. It's alphabetical order backwards. So those are all duplicates to those pre net weight. And there we have it. That is the brute force algorithm for a smaller example. And more vertices, like say we were to return to this example by brute force, there would be 120 unique Hamilton, well, 120 Hamilton circuits, up to 60 unique answers here. It's going to take all day to do all those. And notice that what's obviously preferable to doing that is to use either the cheapest link and the brute force. And if we're getting the same answer from both of them, we're pretty confident that that's probably the best option there is, though not guaranteed. Anyways, that wraps up chapter 6. Hope you all are doing well. See you all online.